Hello friends, today discussion with design of shear reinforcement for reinforced concrete beam. This subject is DRCS. Okay, design of shear reinforcement in RCC beam R20 regulation. Okay, next coming to next example problem. Example problem: a simply supported RCC beam 200 into 400 mm effective is reinforced with 4 bars of 22 mm diameter on tension side. The beam is carrying a load 30 kN per meter over a clear span of 8 meters. Design the shear reinforcement using in M20 grade of concrete and Fe 415 steel. Okay. Next, given data, a simply supported beam RCC beam dimensions 200 into 400 mm is reinforced with 4 bars of 22 mm diameter for axial load. W is equal to 10 kN per meter square. Then clear span, inner to inner span is 8 meters. Using in grade of concrete, M20 grade of concrete and Fe 415 steel. Then this is the given data. Second is nominal shear stress. Find out the nominal shear stress. Then nominal shear stress load you have to given 10 kN per meter square. Then again add the factor load. Factor load 1.5 into total load. Then 1.5 into 30, 45 kN per meter square. Then again step shear force. Shear force Vu is equal to, this is the simply supported beam, like that shear force WL by 2. Then 45 into 8 by 2, 180 kilonewtons. Then nominal shear stress tau V is equal to Vu by Vd, where Vu is equal to shear force, B is equal to breadth of the beam, D is equal to depth of the beam. Then tau V is equal to 180 into 10 power cube by 200 into 400. Then tau V value 2.35 Newton per mm square. Then again step number 3, shear reinforcement of column. Then shear reinforcement of column, first find the percentage of tension steel at support. Then percentage of steel AST by BD into 100. Then refer the IS 456 2000 code book, page number 73. Then percentage of steel AST by BD into 100. Then again where AST is equal to pi into pi d square by 4, area of the dia bars into number of bars. Then finding the AST value. Then again percentage of steel 1520 for area of the steel by breadth of the beam 200 into depth of the beam into 100. Then find the percentage value 1.90. Then again refer the page number 73, table number 19 table. Refer the IS 456 2000 code book. Okay, by using in grade, depending on grade of concrete, then find out the percentage of
by
steel
using
value.
grade of concrete, M20
Then
grade of
again
concrete.
refer this chart.
By refer
then
the table number 19 and page number 73 IS 456 2000 code book. By using in M20 grade concrete 1.75 and that value 0.75. Then 2 value 0.79. By 1.9 value, then finding that value by using an interpolation method. The shear strength of concrete, maximum shear stress, tau V, tau C value. Then find out the YV value. Then YV value is shear strength of concrete value. Shear strength of concrete value. Then tau C. Again, the shear strength value tau C compared to tau V is more than the tau V value. It is design a shear reinforcement for beam. Then again refer the IS 456 2000 code book, table number 20. Then maximum shear stress value. Refer the M20 grade of concrete, tau C maximum 2.8 meters. Okay. Then tau V is 2.35. Then also design a shear reinforcement is applicable. Then another step, design of vertical stirrups. Then design of vertical stirrups. first step, shear resistance of concrete, VU minus tau C into BD. Okay, where VU is equal to shear force, tau C is equal to nominal shear stress, B is equal to breadth of the beam, D is equal to depth of the beam. The shear resistance of providing to the both direction and the two directions. Then shear reinforcement is 118080 by 2. In shear reinforcement applicable in two directions, in two sides. Then shear resistance is 59040 newtons. Then spacing of stirrups for two-legged stirrups. By using in two-legged stirrups, by assuming, then find out the shear force, find out the spacing 0.87 Fi ASPD by VUS. Then Fi is equal to grade of steel, ASP is equal to assuming two-legged stirrups. Then diameter of the bar is 8 mm dia bars. Okay, then finding the ASV value pi d square by 4, 8 mm dia bar, pi into 8 mm dia bar square by 4 into two-legged means of two-legged stirrups. Then area is 100 into 530 mm square. Then find out the spacing 0.87 Fi 415 into ASV into breadth of the section by then shear stress value. Okay, then finding the spacing is 245.910 mm. Then again maximum spacing as per IRC 456 2000 code book. Okay, maximum spacing 0.75 into D. Then D is equal to depth of the beam. Okay, then maximum spacing is 350 mm as far as IS 456 2000 code book. Then finally providing as 8 mm dia bars at two-legged stirrups at 240 mm center to center. Okay, then again minimum, in case of find out the minimum spacing for shear reinforcement, SV is equal to 0.87 Fi ASB by 0.4 into B. Then maximum also 0.75 into D. Then minimum is 0.87 Fi ASB by 0.4 B. Then minimum spacing 453.7 mm. Then finally providing as 8 mm dia bars at two-legged stirrups at spacing of 240 mm center to center. Okay, next step, number of stirrups will be used for this beam. Okay, total length, effective length by spacing. Then where effective length is equal to wall thickness by 2 plus clear span plus wall thickness by 2. Then 8200 mm. Okay, 8200 mm by spacing of stirrups for minimum spacing 240 mm. Then 8200 by 240 mm. Then number of stirrups is 34 numbers. Then finally stirrups is 8 mm dia bars at two-legged stirrups in 34 numbers. Okay, all of you understood this problem. Next, thank you. Okay, thank you.